In this video, I would like to talk about statistical measures of center. Now, we could think about a measure of center as being the middle value in a data set. There's a number of different ways to define the middle of a data set. It depends on what type of data we have. Is it qualitative or quantitative? And the specific values we have within the data set. Another way of thinking about a center value or a middle value is a single representative value for a set of data. I'm not saying numbers, because remember, data just means information. It could be numbers, words, descriptions, categories. Just data is information in general. Now in this video, I want to talk about three of the most common measures of center. These aren't the only ones. We have the arithmetic mean, the median, and the mode. You may come across the mid-range. It's another measure of center. I don't mention it in these notes, but I mentioned it in my other video where I go through all of these topics using Excel. There's another one called the weighted mean. So when you hear the word mean, in statistics, the word mean means average. And there's two types. There's the arithmetic mean, and that's the one you're probably most familiar with. The mean is the average. Add up all the numbers and divide by how many numbers you have. So the word mean in a non-statistics class setting, we say the average. So if you just see the word mean by itself, that means arithmetic mean. So there's two types, arithmetic and geometric. The word mean means arithmetic. Geometric mean is something, we don't use very often, but it's also called the weighted mean. And it's something, if you're a student, especially if you're a college student especially, it's something you're very familiar with because your GPA is a weighted mean. If you take a 4-credit course and get an A, that has more of an effect on your overall GPA than if you take a 1-credit lab and get an A. So different courses are have different weights based on how many credits they are. All right. The next one is the median, and this is literally the middle value. When you put the data in order from smallest to largest, the number sitting in the middle is the median. Now I say number here, not data, because to do this, you have to be working with quantitative data. To put your data in numerical order, they have to have numerical values, so they must be quantitative. So the arithmetic mean and the median, they could only be applied to quantitative data. And then there's the mode, and the mode is the most frequently occurring data value. Now, the mode is interesting because the mode, you can apply the mode to data at the nominal or ordinal levels. So if we're talking about, let's say, eye color, for any set of people in the US, most likely the mode will be brown because brown is the most common eye color. But of course, we can't take the mean or the median of eye color because we can't add, blue plus brown plus green plus hazel divided by 4. That doesn't make sense, right? And median doesn't make sense because we can't rank colors in numerical order. So the mode we could use for data at the nominal level and the ordinal level, or categorical data. All right, so there's going to be a lot of notation in statistics. And to make things even more complicated, each statistical quantity will have 2 symbols. Almost all of them. Once in a while we'll come across, like the median, there's only 1 symbol. But for the most part, each statistical quantity or characteristic has 2 symbols. So you might want to have a page in your notes set aside just for having a list of all the symbols. And you probably want to make it something like this. I would say something like value, sample, and population, or sample, statistic, and population parameter to be more specific. So something like this. For example, the mean. The mean has two symbols. Now, normally what we have is the sample version of the quantity is an English letter, and the population version of the quantity is usually a Greek letter. So for the mean, we have X bar. So anytime you see X bar, that represents the sample mean. And anytime you see the Greek letter mu, that's the U with the long little thing there, that's the population mean. So we have a different symbol for each. And then, not in this video, but in my next video on, or my next set of notes, my next video on measures of variation, I'll have a slide where I have all the symbols all in one place for you. So rather than, do this out yourself, you might want to wait till you look at my next set of notes. Okay, so one more thing on this slide. This symbol here, this capital Greek letter sigma. So when you see this, that means nothing on its own. So by itself, it's like, so having this symbol by itself is like saying, what is this equal to? Well, it's an empty square root. It doesn't equal anything. So just like with the square root, you need a number underneath it. Well, this symbol, sigma, you need something that comes after it. So whatever goes here. So this symbol is, well, we call it the summation. We call it the summation symbol. And that means whatever comes after it, you add up all of those things. So for example, right here, this is saying you add up all of the x values. And then you divide by n. N is the number of values that we have. So we could probably add that to our list. Size of data set. And this is not a calculation, so we don't use the Greek letter here. For the size of the data set, if you see lowercase n, that's the size of your sample. And if you see uppercase N, that's the size of your population. So those are the first two symbols, or I guess the first four symbols we have on our list. And it's important to distinguish between the sample version and the population version and know which symbol goes where. Because if you look at the formula sheet that I have posted, you don't see words, you see symbols, a lot of symbols there. So to know what those formulas are used for, you have to know what the symbols mean contained in those formulas. Now, when we're calculating measures of center and also measures of variation, there's a very specific rounding rule. Whatever it is you're calculating in descriptive statistics, you want your sample statistic to have one more decimal place than your original data. So if I asked everyone in a room, how much change do you have on you? How much money, like hard currency, how much do you have on you at any point in time? Or let's say, how much do you have on you right now? And you may say one person, oh, $1.17, and another person might say, oh, $22, and another person might say, I don't know, 57 cents. 57 cents. And so money is given to two decimal places because it's to the nearest penny. So when we calculated, let's say, the average amount of money that everyone has, we would use 3 decimal places. Always one more decimal place than your original data. All right? Well, for example, so I find the mean data speed for the following 6 Verizon phones, and these are measured in megabits per second. Okay, so you have 6 values here, 1, 2, 3, 4, 5, 6. And our formula says to find the mean, you add up all of the x values and then divide by the number of values. So to find the average of 6 numbers, you add them up and divide by 6. So we have 1, 2, 3, 4, 5, 6 numbers on top, add them up, divide by 6. And since our data is given to 1 decimal place, we're going to round our mean to 2 decimal places. And since this is a 6, it looks like we're going to round that 1 up to a 2, so we should have 30.42. All right, and as I've been saying, I don't want you doing these calculations by hand. I want you using Excel, because if you think about it, to find the average of 6 numbers on a calculator is not that difficult. You punch in the keys, so it looks like 3, 6, 9, 12, 15, 18, 19, 20, 21, 22, 23, 24, 25, 26 keystrokes to do this. So if you type in, 26, 27, 28, 29, 30, 31, 32, sorry, I forgot the decimal point. So 32 keystrokes. To add up these 6 numbers and divide by 6 is 32 keystrokes. But what if we had 600 numbers? So that's approximately 3,000 keystrokes. So for larger data sets, the use of a handheld calculator becomes more and more cumbersome, and then it becomes logistically impossible. So in my notes, if you click here, it will take you to my YouTube video where I work through this problem on Excel. So I show you how to find the average on Excel. You're basically using the function, the formula for mean on Excel is called average. So it's equal average and then location of data, which is the form. Pretty much everything we're going to do in Excel for this course is going to take an equal sign, the name of the function, and then the location of the data. All right. Now, we could also estimate the mean of a data set without having the data set itself, with simply using with simply knowing the frequency distribution of that data set, and the frequency distributions we talked about in an earlier video. So if we don't know the x values of a set, we can estimate those x values as being copies of the class midpoints. Now, how many copies depends on the frequency of the class. All right, so what does this mean? So here's the frequency distribution. These first two columns. That is the frequency distribution. Actually, not the bottom row, just right here. This is what I have in red. This is the frequency distribution. All right, so you have the first class, which is 50 to 69, and the frequency, there's 2 numbers in that class. And then the next class, 70 to 89, and there's 33 numbers in that class. Now, we don't know what those first 2 numbers are, those next 33 numbers are, so we estimate them. And we say, okay, we'll use the class midpoint, which is halfway between the lower and upper limits. The halfway between 50 and 69 is 59.5. So what we do is we say, okay, well, there's 2 of these. So instead of saying 2 numbers here, now we'll say there's 2 copies of the number 59.5. And then there's 33 numbers in the next range. We don't know what those 33 numbers are, so we'll say there's 33 copies of 79.5, and so on. So that's what we're doing here. We're taking f times x, the frequency, that's how many copies there are, times the x value, which we're using the midpoint. All right, so it would be 2 times 59.5. So 2 times 59.5. Then it's 33 times 79.5. Right? Then it's 35 times 99.5, and so on. So we get these 5 numbers here. And then this symbol tells us to add them up. And once we add them up, that's the numerator, then we divide by 78, which is the sum of the frequencies. So if you add up the frequencies, that's also n, the size of your set. This is the 2 numbers plus the 33 numbers plus the 35 numbers plus the 7 plus the 1 tells you there's a total of 78 numbers. So when you add up the frequencies, that gives you the size of your set. Okay, next measure of center, the median. We say the median is the middle value. Well, maybe it's the middle value. There might not be a middle value. It depends if there's an even or an odd number of values. Now, one thing about the median that makes it sometimes more useful than the mean is that it's resistant to outliers. I go into this idea of resistant to outliers in detail in my Excel activity, and there's a link to the video, I think, on the last slide of this set of notes. So, symbol for median, often we use x tilde, the little squiggly bar on top of the x, and the median is the middle value, so it doesn't take into account the smallest and the largest numbers. It just takes into account position. So, for things like, for example, what I use in the Excel video is house prices. So there could be a very extremely high priced house in a neighborhood which will throw off the average value, but it wouldn't throw off the median value. So to calculate the median, first, it's important, first you have to sort the numbers from smallest to largest. And again, this is if you're doing it by hand. Now, if there's an odd number of numbers, if the number of data values is odd, there will be a middle number. If the number of data values is even, there won't be. So we have to take the average of the 2 middle values. I'll have on the next slide, I'll show you a specific example what I mean by this. So find the median. Here's 2 problems. In the first data set, we have 1, 2, 3, 4, 5, 6, 7 numbers. And in the second set, there's 6. Either way, to find the median, we put the data in order. So the 0.42 is the smallest, and then 0.48. So we get rid of the unsorted data, and now we have a sorted list, sorted from smallest to largest. So now we have position 1, 2, 3, 4, 5, 6, 7. And so position 4, if there's an odd number of numbers, position 4 is the middle. You've got 3 numbers to the left, 3 numbers to the right, and the 0.73 is sitting in the middle. But down here, if you have an even number of numbers, the median, or the middle position, is right there. It's halfway between the 0.73 and the 0.10. So if there's an even number of numbers, the median is the average of the 2 middle numbers. Oop, didn't mean to do that. There we go. So, yeah, if there's, well, yeah, so okay, like I said, if there's an odd number of numbers, the median is the middle. If there's an even, it's the average of the 2 in the middle. And again, you could click here to see how you do this on Excel. Again, it's just one step, just like very, very similar to the finding the mean on Excel. Instead of using the word average, it's equal median. And then in parentheses, location of the data. So the final measure of center I'm going to discuss on this slideshow is the mode. And the mode is we were talking earlier about eye color, the mode is the value that occurs with greatest frequency. Now the thing about modes are, there might not be one. And there might be more than one. There might be 2, there might be 5. It all depends on what the actual values are. So if 2 values are both repeated the same number of times with greatest frequency, we say bimodal. Bi means 2. Or if there's more than two values that occur with the same greatest frequency, we say multimodal. So if there's 3 or more modes, we say multimodal. Or it's possible there's no mode. If there's no repeats, there's no mode. And as I said earlier, it's the only one that can be used with data at the nominal level. All right, so if we find the mode of each set, well, in this first set, let's see, it looks like the 1.10 is repeated. And that's the only one that's repeated. In the second set, it looks like there's 3 of these. There's 3 of these. There's only 2 88s and only 1 89, so 27 is repeated 3 times and 55 is repeated 3 times. And then in down here in C, 1, 2, 3, 6, 7, 8, 9, 10, nothing is repeated. So nothing's repeated, so there's no mode. Here the 1.10 was the only number that was repeated, so there's a single mode here, and in B we say bimodal because there's 2 numbers that are both repeated 3 times. All right, so an overall sort of general visual diagram of measures of center. So the mid-range is included here, but it even says the mid-range is rarely used. So we talked about mean, we talked about median, we talked about mode, and then in terms of the choice of when to use the mean or the median. Now let me go to my next slide for a second. In this Excel activity, so if you click here, you'll be able to view the entire process start to finish. I talk about this question, when to use the mean and when to use the median. But basically, the mean is your default. That's sort of plan A. If you want a measure of center for quantitative data, you use the mean unless there's a reason not to. And that reason not to would be if there are extreme values. If there are extreme values, we go to plan B, which is the median. All right, so that about does it for measures of center. There's a little bit more detail to the problem, but this is just the sort of the bones of it. So if you click on this link, it'll take you to a problem where I sort of explore the measures of center to a data set with and without extreme values. Okay.